right, so I want to label this food lab, and this would have been the one you did in class. And unfortunately, because we weren't in class, you saw my video of actually me performing the lab. Let me see if I can focus that a little better. Okay. This is unit 9, so let's just keep track of the units and write that in there so we can make sure we don't make a mistake. So there's a lot of information that we got from the video. I will go over the marshmallow. So we burned a marshmallow that we burned. And there's information that through the video, you can hear me announce as I was going through it. First of all, we knew, or I mentioned that we used 100 milliliters of water. There is a 1-to-1 ratio of milliliters to grams. So that means I've used 100 grams of water. So now I'm just stating all my data. Keeps going in and out for focus. Let's make sure we get it focused. And then we had the food, so the marshmallow, with the device. And the device was that cork with the paper clip connected to it. And we measured it. And so the before it was burned, I'll just put before burned, it measured 71.54 grams. And then after it was burned, it measured 70.73 grams. So the difference is 81 grams. So this is how much we burned. And that's the important value, is the end result, the difference between the two. We also took the temperature in the calorimeter in that pop cam, and the initial temperature was 24 degrees Celsius, which is about correct because that was room temperature. So we expect it to be around 24, 25 degrees. And then my final temperature, after we burned the item, we kept the thermometer in the can, and we got to 33 degrees Celsius. So the value, the difference, or my change of T is going to be 9 degrees Celsius. 33 minus 24, giving me 9. So this is lab, and I need to use the MC delta T equation. But the first problem actually asks you to solve it in joules. So this is a key component of what do I need to change then? I need to make sure my specific heat value is in joules so I get the correct answer. So my mass that I use is going to be the mass of the water only, because again, this is a burning combustion type, right? We're burning in, it's the measurement of what's in the can. We don't have the chemical dissolved within. So we're using 100 grams of water. Then the specific heat value. Because I asked you to find it in joule, you need to solve or use the specific heat value in joules, which is 4.18 joules divided by grams times degrees Celsius. The change of temperature was the final minus the initial, which gave me 9 degrees. So I can cancel, 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 and I'm left in joule. So then I'll take my calculator, right? And I can go 100 times 4.18 times 9, and I get 3,762. 3,762 joules. However, this is how much was absorbed by the water. So to indicate how much was given off by the marshmallow, we merely just change the symbol. So now I'll box it in because that was my final answer. The second part to that question actually asks you to solve it in calories. Not chemical calories, but food calories. So I saw a couple variations. Some students automatically just converted the little chemical calories to decimal value for your delta C. That works completely correctly. Or you can just solve for little c calories and then convert into food calories. Little c calories, again, is chemical calories, and this is a food calorie, which is what we're trying to solve. So I'm going to then put my 100 grams of water, and then I'll solve for chemical calories first. So that's more of what we did in class. And then we have the change of temperature. Cancel. And then we end up getting 900. I'm sorry, 100 times 9, 900. And that's only chemical calories, right? Change the symbol because that's how much was given off by the food. It's only chemical calories, and I'm asking you for food calories. So to convert it, we divide by 1,000, or it's the same thing as moving it over 3 decimal values. So now, oops, sorry, that shouldn't be there. So now I'm going to put 0.9 food calorie. Again, this is food, and this is chemical. If you didn't write it down yet, you want to make sure that you write it down somewhere. All right, so we have food calorie and chemical calorie. And then it asks you to find the calories, food calories per gram that we burned. Well, we have solved for food calories, so 9 food calories. And let's look above. We burned 0.81 grams. So 0.81 grams. Take my calculator, clear it out. 0.9 divided by 0.81. I'm sorry, that was kind of fast. 1.11111 repeating. So I'll just put 1.11 calories per gram. And again, regarding that negative value, that's just indicating a release from the actual item that we burned, in this case, the marshmallow. So we don't actually need the negative value when we're doing calories per gram, because we're going to be using that to compare to the actual. So let's do the last portion, which is actually, I think, number 2 on that food lab. And we need to calculate the actual. Well, this is where on the back of the bag, I look at the nutritional value. So actual, theoretical, all the same meaning. On the back of the bag, it said 100 calories per 29 grams. So if you divide that out, you get, let's make sure I get that, 100 grams, 100 calories rather, divided by 29 grams. You get 3.448. That's calories per gram. So now you have your experimental from the lab, and you have your actual from the package, and then you do the setup. So your absolute value, your actual or theoretical, minus your experimental over your actual times 100. Let's finalize this answer. Get 3.44 minus 1.11. Let's put that 448 since I used it. And then get 3.448. So I'll type in 3.448 minus 1.11. And then divide by 3.448. And I get this decimal value. And then don't forget, you have to move the decimal value over to get the percent, multiply by 100, and you get 67.81%. And that's the error. So 67.81%, that's not bad, because this is an actual lab that we performed, or rather I performed in class. 67% error, it sounds high, but considering that we're just using an open flame and collecting through a calorimeter of a pop can, that's not a bad percent error. I'm going to stop the recording right now.